Okay, we're in section 1.6 where we get to classify polygons. Definition of polygon is up there on the screen. It's a 2D figure that is formed by 3 or more sides, and the only spot where line segments intersect is at the endpoints. So if you look at the diagram here, example of a polygon, all of the line segments here represented are called sides, and anything inside of those sides is called the interior. Now, to classify or to determine whether a figure is a polygon or not, it has to meet these certain requirements. First off, it must be a closed surface, so it cannot be a polygon if there's this opening right here. Alright, it doesn't work that way. And if there has to be no curved surfaces. So you see this little curve right here? It's not a line segment. So since it's not a line segment, that means it's not a polygon. Finally, there are no line segments inside the interior. So we have this little line segment right here. It is in between, or it goes through the interior, which means it doesn't qualify as a polygon. Once we do decide whether a figure is a polygon or not, in this case, this example of these two are in fact polygons, we then go into another subset where we classify those polygons as either convex or concave polygons. And here's how we do it. I like to call this the ruler method. The ruler method is this. You're going to take a straight edge and you're going to line it up to each side of the polygon. So for the figure on the left, I'm going to take a straight edge and put it right here. And if the straight edge does not intersect the interior of that side, then I go to the next one. Something like this, 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 here, and then finally here. And in this case, my straight edge did not intersect the interior when I put it on every side. So since it didn't intersect on any side that I chose, this is an example of a convex polygon. So you're going to use that same ruler method on the next one. So if you go over here, no intersection, no intersection, no intersection, no intersection, and then finally I get to this one. Ooh, I have an intersection. Since it intersected this interior with that one side, so as long as one side intersects, we can say that this is a concave polygon. Okay. Other classifications of polygons are determined by their number of sides. So there are some more mainstream ones where you have 3 sides is a triangle, 4 sides a quadrilateral, 5 sides a pentagon, so on and so forth. Anytime you get into sides that are larger than 13, we have what is called a whatever number of sides it has, it's a gon. So if it's like a 20th gon, that means it has 20 sides. Another thing that we can classify polygons is polygons can be what are called regular polygons. Regular polygons have 2 distinct characteristics. The first thing is that all the sides are the same, and all the angles are the same. So it has to meet both of those criteria for them to be a regular polygon. In this case here, this is how many sides? 1, 2, 3, 4, 5, 6, 7, 8. So this would be an example of a regular octagon. Okay. If it only has one of the characteristics, so if it just had all the sides are the same, or all the sides are congruent, it'd be called a equilateral polygon. And then if all of the angles were the same, but not all the sides were the same, it would be considered an equiangular polygon. this here, I'm going to ask you to draw a figure that best fits the description. What I'd have you do if you're watching this video is hit pause, do one yourself, and then see if you get something similar or if it meets the criteria of the problem. So if you give it a shot, hopefully you did. I'm going to give you my best drawing of what it should look like. Doesn't say it necessarily has to be that way, but it could be. The first one was a concave polygon, a pentagon. So a pentagon is a five-sided figure, and a concave is where at least one of the sides, when I do my little ruler method, that it's going to intersect the interior of a polygon. So I go, let's say, look something like this. So that's 1, 2, 3, 4, and then 5. So I got my five-sided figure, and then at least one of my rulers would intersect the interior. Next would be an equilateral 15 con. So I want to make a side. So this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And even though they don't appear to be the same length, the tick marks are there to represent that they in fact are all the same. My artwork is the greatest. Next, we're going to do a regular quadrilateral. Now, regular meant that both the sides and angles had to be congruent. So, drawing my four-sided figure, and I'm establishing that all the sides are the same, and that all of my angles are the same. And in this particular one, it has a very specific name. This would be a square. Look over here. We have ourselves a regular hexagon, and we're going to solve for x. So regular again meant that all of the sides are the same, and all of the angles are congruent as well, and we want to solve for x. So all we got to do is, since I know that this and this are the exact same thing, I'm going to set them equal to each other. So I take 3x plus 6, and I'm going to set it equal to 4x minus 2. I'm going to subtract 3x to both sides, which gives me 6 on the left-hand side, and I'm left with x minus 2 on the right-hand side. Solve for x, I'm going to add 2 to both sides, so then x equals 8. And they were looking for x, so I solved the problem. If they wanted to know what the sides were, you can just plug it in. So you can take like 4 times 8, subtract it by 2, 32 minus 2, which gives you 30. And you would get 30 from each one of the sides. Last thing we talked about in class is there a possibility that we could draw a concave regular polygon? From discussions in class, it's not possible. The reason for that is because of the definition of regular. It means that all of the, say I can make all the sides the same, that can be true, but this angle right here would be different than, like, say, this one. So we could have a equilateral concave polygon, but we certainly could not have a regular polygon that's concave. And that is beginning to classify polygons. Hope this helps. Till next time.